introduction. Hello, everyone, and I would like to appreciate you all for attending my presentation. My name is Fereshteh-Ahmadi. I'm second-year PhD student at Northumbria University, Newcastle. The title of my paper is about exploring causal loops in resilient maintenance operations of built asset, which is a literature review paper. Here is a summary of topics I'm talking today. So I'll start with the importance of maintenance management, disruption to maintenance operation, the importance of resilience maintenance operation, research methodology, causal loop diagram, further study, and conclusion. As we are all aware, operation and maintenance is a very important phase of asset life cycle. O&M is the longest and costliest phase in asset life cycle, accounts up to 80% of the asset life cycle cost, and have a significant impact on systems' ability to maintain or restore its performance. Maintenance management is a very complex process due to the requirement of incorporating a variety of maintenance aspects such as time management, risk management, asset management, inventory management, and so on. Therefore, maintenance represents a crucial part of various European legislation. For example, maintenance standard published EN 13306 and other standards. Also, British standards incorporating a European standard published a series of ISO 55000 and ISO 19650 delivery phase of, which is about chapter 2, which is about delivery phase of assets, and part 3, operational phase of assets. Okay, maintenance management makes sure that the asset will be available and accessible and reliable to the users. But according to the research, number of disruptions, natural disasters, or man-made one are increasing. Therefore, we are focusing on exploring and identifying different types of disruptions, because these disruptions will impact on people, environment, and can economic loss. For example, we in UK experienced several floods, as you can see in the photo, which can cause disruptions in transporting and has impact on the users for a couple of days. Other example, in 2021, 3 snowstorming knocked out the energy infrastructure in Texas, leading to shortage of water, food, heat, and leaving more than 4 million homes without power. So this is a problem statement, and we start to think about the event and major disruption that have impact on system downtime and system breakdown. By reviewing literature, we identified 3 types of disruptions and classify them into 3 categories. These disruptions could be internal to the organization, external to the organization, but internal to the maintenance process, and external to the organization. So as a solution, we talked about resilience. Resilience is the possible solution to all these disruptions, and there is an immediate need for a resilient strategy to improve responsiveness of assets to disruption or unexpected event. Therefore, we focus on low-frequent disruptions because we believe that we are equipped to overcome high-frequent disruptions, such as day-to-day disruptions. And it says that it has been estimated for every $1 invested in resilience project is possible to get return of between $5 to $10. So as you can see in this diagram that has been published by Sun, it's explained the resilience. I would like to add that resilience has become a key performance indicator to maintain vital functionality and physical condition of assets, reduce unexpected failure and downtime, ensuring system safety and minimizing vulnerability to the disruptions. Sun proposed 3 resilience capacities such as absorption, adoption, and restoration, which we are aiming to increase these capacities in order to face with the disruption and minimize the impact of disruptions. Which I want to explain these capacities. Absorption is the ability of a system to absorb the consequences of disruptions and return to its normal normal and original state. Adoption is the ability of a system to recover a certain amount of lost performance without the need of external maintenance actions. And in restoration, once we achieve to the restoration phase, we might have a newer performance level, lower, equal, or greater. Here is the research methodology for this paper. So obviously we start with defining the problem. So we start with defining the problem through the literature review, and we realize that there is a research gap for improving resilience of maintenance operation. And then we, the second stage, we start with analyzing maintenance operation process for built asset in different systems. Again, through literature review, through reviewing literature and interviewing with experts, and exploring potential root causes of major disruption in maintenance operation and their consequences in the system. So again, reviewing literature, interviewing experts, and developing system thinking model using root cause analysis. So after that, we came up with a taxonomy, and which we used this taxonomy to develop causal feedback loop. This is a very brief, very first draft of the taxonomy that, as you can see, is very complex system, and there are many factors that have impact on maintenance operations. And this has been extracted from reviewing literatures. And to classify disruptions, as I mentioned earlier, there is three main classification of disruptions: internal to the organization, external to the organization, but again, internal to maintenance, external to the organization. And each of these main categories have two subcategories. For example, maintenance process, which is about how we provide like maintenance crew or training or budget and so on. And control disruptions, which is involve the regulations, rules, standards to control maintenance process, belongs to the internal to the organization. Demand disruptions is the gap between actual and anticipated demand, which has impact on the flow of material or information. And supply disruption, which once we fail to supply spare parts or disruption to the flow of the product. These two subcategories belong to external to the organization, but internal to the maintenance process. And external to the organizations, these disruptions, these are that we don't have any control on them, and such as environmental disruptions and human-made disruptions. Here is a causal feedback loop, which is the contribution of my knowledge in this paper. We use the system dynamic to develop causal feedback loop because we believe that maintenance management have a dynamic behavior, and we use CLD for demonstrate the causality and interrelationship between identified disruptions, their variable and sources. CLD is one of the SC modeling that represent complex feedback process and non-linear relationship between component and can be developed through gaining knowledge about the system as well as brainstorming or discussion. In addition, there are some causes whose sources are independent of the system itself. However, it impacts on the system downtime. SC shows how components interact throughout the system by going beyond the event and searching for the behavior pattern. For the future studies or further research, as you can see, we are at stage 0, developing causal feedback loop. Once it's validated, we might be able to develop a conceptual simulation-based framework, because the main aim of the further research is to develop simulation-based decision support system for improving resilience maintenance of operations. So the first step was to develop this causal feedback loop, and then once this validated, we develop a conceptual simulation-based framework, and then create a base model for simulation, the normal maintenance operation, modeling potential disruption scenarios to apply to the base model. In this case, we will have two scenarios: in the absence or in the presence of the disruption, and in the absence or in the presence of mitigations plan, and implement the developed framework in a use case. And the final aim is to develop decision support system for improving maintenance operations. As a conclusion, literature shows that there is a lack of clarity in the maintenance operation resilience definition, concept, and strategies. Therefore, this research emphasizes on increasing knowledge and level of awareness to the practitioners and industry. And as a result of this academic and as a result of this research, academics and practitioners are better equipped with the technological advances that support predictive maintenance, such as simulation, for improving resilience of maintenance operations. The recommendation of this paper is that we believe that most of the organizations, they are focusing on disruption, what has happened, and we want to focus most on post-disruption stage, investigating on post-disruption stage and its management. So, yeah, that's it. Thank you.